So guys, we are going to learn our new chapter, which is significant figure. Okay, significant figure. And the thing is, I consider it is a easy chapter but an important one, and most of the places this is people don't teach it because they thought it's an insignificant chapter, yet I feel it's a significant one. So let's start with the significant figure, this chapter, and I'll start with a problem. So the problem is very simple. Even you might think it's not a problem anymore. So this is the problem. I give this is 3 kilometer, and I want you, how do you write it as? Further write it as like this, 3000 meter, like this, 3 into 10 is to 3 meter, or like this, 4 meter, or I will say all of these. So this is my question, and most of you might be wondering, you can pause the video and think over it length, but I think most of you might be wondering that this is a very easy question, and some of you might be thinking this is not a question anymore. This is not a question. They do not regard it as a question, and they must be thinking the option of this is D. But I must say D is wrong. If D is wrong, then you must be thinking which is the correct answer. Answer is only one, and that is C. And that is C. And how is it C? We gonna learn it in this video. Okay, so let's move ahead. So what is a significant figure? First of all, so significant figure represent, in a measurement, significant figure in a measurement represent the digits with which you are comfortable or confident with. If you have a measurement, if you have, like you measure something and it is like 3.2 kilometer or 3 kilometer, 3.2 kilometer, you measure the distance. So significant figure tells, then if I've said here the number of significant figures are 2, so that means you are confident with 2 digits here, that the measurement is correct. I'm confident to the 2 places. Okay, if you say significant figure here is 2, I'm just giving you an example. So for 2 digits you are comfortable. For 2 means 2 place you are confident or comfortable. The right word is confident with. Okay, so let's move ahead. I'll express and share with you some rules to determine the number of the significant figures. Okay, so rules, there are some rules. So rule number 1, first of all non-zeros are significant figure. All non-zero digits are significant figure. Non-zero are significant figure. All non-zero in a measurement. If I give you a term or mathematical number, so non-zero is, if I say 1 2 3 4, how many significant figure are there? How many non-zero digits are there? 4. So 4 significant figure. Okay, if I say 1004, so how many significant figure are? 4. How many non-zero digits are? Okay, I'll explain this in a bit. Okay, this is here also there are 4 significant figure, but here I introduce a 0. I need to tell this you in a separate rule, I think. So if I said you, like, I'll ask you 1.35, so how many significant figure are here? 3 non-zero, 3. Okay, second rule, trap zeros are significant figure. Second rule is trap zeros are significant figure. if there are trap 0. And what is a trap 0? I think you got me. Here I use this example 1004. So here trap 0 between non-zero, between two non-zeros are significant figure. So how many significant figure here? 4, because there are two zeros and two non-zeros, so zeros are trapped between the two non-zeros, so 4 significant figure. Okay, and then I can use an example. The another rule, we'll discuss the another rule, that is leading zeros are never significant. Leading zeros are never significant. You just need to just go through these videos, and these videos are ample to give you clear idea about significant figure rather than any book, any notes. So just pay attention. Leading zeros are never significant. Say for example, I say 1.0001. So how many significant figure are there? Then you will say there are the leading zero, so there is only one significant figure because these are the leading zeros. Okay, so let's move ahead. Now the rule number 4th, I give you 3 rules. So rule 4th is ending zeros after decimal are significant. Okay, ending zeros after decimal, it has to be after decimal. Ending zeros after decimal are significant figure. Say for example, I say 2.00. How many significant digit it have? There is one non-zero, there is 2, and there are 2 zeros, but the 2 zeros are after decimal, so there are 3 significant figure. Remember that is very important. Now you're confident with 3 places over here. 2.00, otherwise you just give 2 na, so you can measure in points as well. So that means that represent this. How many significant figure are here? Only 1. Okay, if I say 200, how many significant figure are here? In case of the 200, only 1, because these zeros are not after point, are not after decimal. Okay, say for example, if I say 3.230, how many significant figure are there? 4, because this 0 is after the decimal place. 4 significant figure. Okay, just pay attention. If I say 0.0003, how many significant figure are there? Remember the previous rule, only 1 significant figure are there. Okay, if I ask you what is this 0204, how many significant figure are there? Leading zero are never significant, but this is the 0 between two non-zero, so 3 significant figure. Okay, if I ask you another like 0.0000320, how many significant figure are there? Leading zeros are never significant. But zeros after non-zero are significant only when there comes after decimal. So here there are 3 significant figure. Okay, can you feel that? Okay, I can give you the exact feeling what does that significant figure represent. Okay, well, let's move ahead, and I give you everything. I want to ask you one thing. If I ask you how many significant figure here and how many significant figure here? Both are same or different? In this case it is only 3 significant figure. In this case this is a good one. See, these are significant, but 0 is significant or non-significant? After the non-zero it is non-significant, but zeros after a decimal point are significant. So these two are significant, and anything between two significant figure is also significant. So this makes this 0 also significant. So there are 6 significant figures. So this example is very important. It's very thoughtful, and make your conceptual. So the thing is, decimal between two significant figure, another figure has to be significant. Okay, so there are 6 significant figure here. Okay, now there is one more important thing. In case of the significant figure, order is never significant. This is I think 6th or 5th order of magnitude. Order of magnitude, that means when you measure something and write in terms of the order means in power, is never significant. Okay, and what does that mean? I'll tell you. If I say something like that, 2 into 10 raised to power 5, so what is how many significant figure are there? Only one. Don't take this into significant figure. If I write something like that, 201.0 into 10 raised to power 4, how many significant figure are there? 3, and point 0 after point is also significant. 4 significant figure. Okay, 4 significant figure here. You're getting it? Order is never significant. Say, you can also feel that now. If I say that 200 is the case, 200 is the case. So in case of the 200, how many significant figure here? Only one. Only one significant figure. 0 doesn't count until they come after point. So if there is one significant figure, I can convert this into 2 into 10 to the power 3. Oh, sorry, 2. So how many significant figure are there? Only one. So my question to you is, can I convert 200 into like 0.2 into 10 to the power 3, or can I convert it into 0.02 into 10 to the power 4? Which one is correct out of the two? You need to think that. Of course this is correct, this is not, because here significant figure are 1 only. Here they are, but is also 1. I've told you, preceding zeros are never significant, so both are correct. But the thing is, order we are not taking. Order is not be taken into significance. Okay, somewhere it is 3, somewhere it is 4, it doesn't matter. All of them have same significant figure, that is 1. Okay, then we'll discuss more in the next video.